Hello, YouTube. Welcome back to another LeetCode problem solving tutorial. Today we are going to do a reverse linked list. Sorry I didn't really upload for the past few days. I've been trying to actually solve this problem and it's been pretty rough on my recursion part, but I think I understand it now, so I am able to teach you guys how to solve this problem. Yeah, let's go on to the question. It says, given the head of a singly linked list, reverse the list and return the reversed list. So if we're given an example, 1, 2, 3, 4, and 5, then what it wants us to do with this linked list is we want to return 5, 4, 3, 2, 1, and then null at the end. This also has null at the end. So that's the basic premise of this problem. Hopefully you guys understand it. And if we're given a head which is nothing, so we're also given this head of the linked list. So this is going to be our head. So our starting point. So how would we basically solve this problem? So first of all, we need to learn how to set this 1 to have a reversed pointer. What does that even mean? That means we want it to look like this and it points to null. Because if you look up here, it's going to go like 2, 3, 4, 5. What we want to do is change this arrow to point to the previous node. So how we would solve this is we need some sort of previous value. So we set that to null. And then we have another value that tells us where we're at in this linked list, right? So if we're at 1, how are we supposed to go forward? Well, to go forward in a linked list, what we need to do is, so this is our current pointer. So we move our current pointer to the next value. So that means we would move this here, and then we would move this here, then here, then here. And then once we get over here, we would say, okay, we've processed every node in this linked list. So as we move along, right, we have this previous value. And as we move along, we want to set our previous value to our current value when we move forward. So at the end of our iteration, we would end up over here, and then we need to return our previous value, which is going to be 5. We have to return 5, and that's going to be our end of the linked list. But we're going to start with a smaller example because dealing with 5 nodes is pretty, like, if I were to explain it, it would be a long process. So we're just going to have 3 nodes, 1, 2, and 3. So first of all, we need to say, okay, we have a current value, right? And then we have a previous value, okay, which is null. So if we're over here, we need to be like, okay, since we're at the current value, we want to set this number 1 node next value to equal to null, right? So we would say cur.next equal to previous value. This is what it's going to look like in our code. So when we do this green arrow and we set it to our previous value, we say cur.next equals prev. But then, okay, so how do we get to this number 2 value, right? How do we get over here? Since we don't have a reference anymore, we set the current's next value to equal to null. So if we say current.next again, that's going to be like, we can't reference number 2 because we broke this link. It's like not there anymore. So first, what we need to do is we need to store this 2 somewhere before we do cur.next. So it would look like this next, right? So next, we need to store this next value before we break this link. Hopefully that makes sense to you guys. So next would be equal to cur.next. So this is basically how we would, this code is how we would reverse 1 node. What we need to do is we need to have our previous value, and that is going to equal to null in the beginning. Then we have a while loop, and then we can just say cur, and then we say cur equals the head that we have right now. So while the current value does not equal null, so when the current value, which is this one, once it gets over here, then we would break out of this while loop. Now we just need to use this cur next and cur.next, okay? So we just say next is equal to cur.next. Then we can say cur.next equals previous. Since we already stored number 2, we can hook up this link, cur.next equal previous. Then what we would do is we would move this current value to our next value and our previous value to our current. But we want to set the previous first before we move this current pointer. Because if you move this current pointer first, right, and we set the previous value to our current pointer, then our previous and current pointer would be here, and we don't want that. That's why we need to do this previous pointer first. Then we set our previous to our current pointer. Then we say cur equal current dot next. So when I say cur is current dot next, that means this guy dot next. So what is dot next? This guy. But if we say cur dot next, that means we're actually referencing this green arrow, right? We don't want the green arrow. That's why we store this next value. That's why over here it's just going to be next. That was the whole point of saving the next value. Then, so once it travels through the whole linked list, right? While it gets over here, our current value is now going to be here, and our previous value is actually going to point to 3. Then we just say return our previous value. And believe it or not, this is the whole iterative code. So that's just like going one way. The runtime complexity of this is going to be big O of n, because n is actually the number of nodes that we have in this list, this linked list, because we have to traverse through every single node. And that's why it's O of n, because if we have like 10 nodes, it's going to be 10 seconds. And if we have 20 nodes, then the time increases in a linear pattern. So it goes like this, right? Let's just think this line is straight. So it's like for each node, time goes up. So that is going to be time. And our space complexity, right? We're going to say it is a constant, because the only space we're actually storing here is these 3 values, which is this current value, this next value, and our previous value. Like these arrows up here, current, next, and previous. So we have to store that. But it doesn't matter how big our list gets. It's still going to be 3 for like, it doesn't matter how much nodes there are. And that's why we have a space of 3, space of constant. So how we would write that in Python is we just say we need our previous equal to null. That's starting from here. Let's just circle this so we would know what we're copying. Previous equal null, we need to set our current equals to head. Then we say while current is not equal to none. Then what we can do is we need to save our next value, save this next value, link up this chain, and then we push these pointers forward. So we would do previous and then current. First, save our next value, next node value equal to current dot next. Then what we say is we link up the chains, right? So then you say current dot next equal to previous value. Then we set our previous value to our current value. Then we set our current value to go on to the next node. After we're done with doing this 4 thing, which is saving next, linking up chain, and putting the 2 arrows forward, then we can say return our previous value. So it should work, guys. Oh, current does not equal none. Oh, it's because we have to set this current, right, into the next node. So that's why we stored it here. My bad. So it should be fine now. That's why we have in our code. Now we submit. And we can check that it works well. So now we will do this code, but now in Lua. Prerequisite for you guys, like doing it in Lua, you're going to need to have a linked list class. So we have a linked list class, which is this, and our node class. This node is actually going to set up our linked list, but this linked list is going to help us set up our test case values. So we can just put 1, 2, 3, 4, 5 into this linked list. And this node is actually what is our next and our value. So I have a video of a linked list, and it will be on the top right. You guys can click that if you guys need to know more details about it. Anyways, let's go into our coding now. I'm going to import these modules. So we have our node class, and our linked list class. Okay, I'm going to set out these test case values. I have the first test case, second test case, and then our third test case, which is going to be empty. But in my linked list class, if it's empty, what happens is that it's going to be nil. So we're just going to return nil. Or I didn't want to do something like this because it's kind of weird if I do something like this. It's totally fine, but yeah, it's just going to have a value of nil and whatever. So we're just going to return nil for this test case. Okay, now let's start writing the defining function here. So we can call these test cases with these functions, which is reverse list. And it takes in a head property. Then we can just say, okay, we have everything to print out our test case correctly. So now guys, we're just going to have to say our current equals our head. And it is totally fine if we just use our head for this this current value. So you can just replace everything with head, right? But I don't want to do that. I want to make it readable for you guys. So that's why I'm using current, because we can just keep increasing the head value. But anyways, previous equal nil. So while current does not equal null, while there is a current, if in Lua, it checks if this is, it has a value. So if it's not nil, so that's what while current do. You can also say it like this for Python as well if you guys wanted to, but we're going to focus on Lua. So what we want to do first is what we want to do is save our next value, update the chain, and then increase the values. So hopefully you guys like understand it. Like this is step 1, step 2, step 3. So let's save our value first. So local next node current next. Then we will update the chain to set it to our previous value. Then we will say update the previous value to our current value. Then we will set our current value to our next node. And then after all this, we will just return previous because we're going to get over here. And that's why we return previous. And then this should work. It's the same thing as our last code in Python. Just make sure that these things are linked up together. That's why we're storing current.next. And then we should be good to go. Make sure we run through we update it, and then make sure we set the previous to our current. I'm going to run it, and then you guys can see 5, 4, 3, 2, 1, and nil because we don't have anything in this test case. Yeah, that is the Lua solution. Now what we will do is we will do a recursive function to solve this problem, right? Because in here, this is a follow-up. You can either do it recursively or iteratively. We did it iteratively first. Now we'll do it recursively. In a recursive function, what happens is that we have to make a function that calls itself. So let's say our function is recursive. So this is going to be our function, and we're giving it a name of recursive. We're going to have something like this in a recursive function, right? But how do we know when to stop this recursive function? We need to like have something in the middle that is a base case. So let's say our base case is like over here. Then we would say, okay, if for example, our head and head equal null, then we would break out of this recursive function by doing a return call. And we would return what? We would return this value. So our previous value, and then we need our current value, which is our head value. We can say it as our head value as well. If it equals null, then we would return the previous value. Hopefully that makes sense to you guys. We're going to return prev here. So this is kind of like what our recursive function will look like. But instead of doing rec, we're going to give it a head. And then we need to give it a previous, because our previous in our initialization process is going to look like this. We have a current, and then we have a previous, and then we need to pass in 1 and also 0. So 0 goes here, 1 goes here. So when we say recursive the function, we're going to, how do we update our previous node to be our current node, right? So what we would do is we would say rec at head.next. But as you guys saw in this last solution, we don't really set our current.next to the next current, we got to actually store our next value, right? So instead of doing head.next, what we need to actually do is update we have to have like some sort of next value here, right? And so our function is going to be like if our head equals null, because we need the base case, right? It's this thing over here. If our head equals to null, then what would we return? We would return this 3 value. We would want to return this 3 value. So we just say return previous. So this is going to be our if. What is going to be our else? Then our else is going to do the recursive call. So our else is going to be the one that controls this head pointer and goes forward. So what we can do is, how do we set our head to the next value, right? Oh, actually our next has to go here. Sorry about that little confusion. Because yeah, we're setting our next is our head to our next value. This is why I'm kind of a little confused on recursion, but it should be fine. I've, practiced a little bit. So this is where our next value is going to be. And then what goes in our previous, right? Our previous value is going to be our head that we had. So our head, our previous it turns into our head. Hopefully this makes sense to you guys now. And then I'll run it through so you guys can see like how this code works. Right now, we're just gonna code it just so you guys can see. Then, well, you guys saw like we had a previous and current and next. It's the same implementation, but it's going to be recursive now. So 1, 2, 3. So we have a prev, cur, and next. So our next, how do we store our next value, right? Then we say next equal head dot next. And my brush is so big right now, sorry. So then how do we update our head dot next? Because we want to update the chain, right? We want to update the 1 points to null. Then we just say head dot next equal, how do we get null again? We say previous here. Head dot next equal previous. So then we update the values. So we update our head value and we update our previous value. How would we update our head and previous value? Well, you pass it into this function, and this also has to return, this returns rec of something. Because once we return our base case, once we get over here, we want to return 3 all the way up. So what does that even mean? I'll show you guys soon after we code this. Sorry, I'm gonna get more space here for you guys. So then, this is actually the whole code, believe it or not. But we will run through a recursive call stack so you guys can see what's actually happening, because recursion is kind of difficult for me. So let's start with our first value. We're going to use a recursive call stack on this 1, 2, 3 and null. Okay. So if we set our recursive call stack, we give it our head, which is we start with 1, and then we give it a null value, right? So recursive 1 and null. What does this return? Okay, well, we wanted to return this value, but let's just say, is our head equal to null? So is this guy equal to null? No. Since it's not equal to null, this is an actual node value, then we will go on to the next one. So it's going to get its next value. So next, it's going to equal to 2. You guys see that? Because if our head starts from here, our next values gets 2. So our next is going to be 2. And then we're going to say, okay, head.next. Our head.next is going to equal to our previous value, which is null. So then what we can say is we return our rec at 2 out of 2, which is our next value here, and our head is going to be 1. So then we say, okay, so what is rec to 1? So we do not know what rec to 1 is. That means we have to do recursive function on 2 and 1. So then that means our next is going to equal to 3, our h.next. I'm just going to call it like this. Head is going to be 2.next equal to, it's going to be equal to our previous value. So it's going to be 1. Then we return rec of 3 out of 2. Okay, then we're going to be like, okay, what is rec 3 of 2? Well, we don't know what rec 3 of 2 is yet. So let's do rec 3 of 2. So then you say our next is going to be equal to null because 3's next value is equal to null. You guys see that? And then our 3.next will equal to our previous value. Then we're going to be like, okay, let's return null and 3. So now that we see, oh wow, our head is equal to null. You guys see this? This is our head value. And this is our code. So once head equals to null, then we would return our previous value, which is 3. You guys see here? So we would return, since null equals null, then we would return 3. You guys see this? And we want to return 3 all the way up because we're going to be like, okay, well, we know what rec 2 of we know what rec 3 of 2 is. It's going to be this value. And what is this value? Well, this value is equal to 3 because you guys see over here, we return 3, which is our previous value. So then it's going to be like, okay, well, I know what this is now. It returns 3. Then this is going to be like, okay, this value is going to be equal to 3 now. So then we're going to be like, whoa, we have 3, 2 now. We know that this equals 3. You guys see that? Then we're going to be like, oh my gosh. Okay, so we return this value back to this rec 2 out of 1. So then it's going to be like, okay, we know what rec 2 of 1 is equal to now. We're going to say it's equal to 3. Then we're going to be like, oh, okay, we know what rec 2 out of 3 equals to 3. Then we're going to be like, oh, since, what are we returning here? What are we returning to this function call? We're returning 3. So 3 is actually the node, believe it or not. It's going to be this. We're returning 3 all the way back up. And that is, so once we return this value, our list is going to actually look like this now because we've been updating our node with these calls. Hopefully that makes sense to you guys. And yeah, I mean, it's a long process. It could get bigger with, 5 nodes. That's why I wanted to do 3 nodes. Anyways, we're going to code it up right now. We know that our solution works. So we just need to say recursive function and pass in the head and what. Well, we need to give it our previous, but we got to actually make it a function. So we're actually coding it in Python now. So then what do we return at the end, right? So return previous value. Actually, we return cursive because this recursive, right, is going to give us 3. It's going to make us go all the way back up. And this one is going to be our next value, next node. And this one is going to be our next. Now it's going to be equal to our head, which is equal to our current value. So we're going to replace head with our current. So it's more readable for you guys. And then over here, like after we do this call, we got to actually call it for this guy. So we just return recursive. And what do we initiate our current for, right? How do we like set this up? Well, we got to say recursion 1 and null. Hopefully that makes sense for you guys. 1, which is head, and none. All right, now we have to have our if statement. If there is a current, then we would say if not current, then we would return our previous value. That means once we get over here, right, our current is equal to null, then we would return our previous value. And now we just say else next node equal current.next. And then this part is saving our number 2, all right, if we were setting our number 1. And then our current.next is going to equal to previous value. That's why this is like store the chain or store our next value, which is 2. And then update the chain to our previous value. And then this is all we need for our recursive. I know, all that big headache just for like 5 lines of code. It's crazy. And then we can run it. and then we see that it works. And then, yeah, this doing not current, by the way, is going to look like this, but you know, not current is less lines of code. Oh wait, we already submitted it. So now we will do it in Roblox. We'll do it in Lua. So if we say reverse list, we're going to need a helper function. That's what we would call it. And you don't need to call it recursive. You can just call it like a helper function. This is going to be our current node. This is going to be our previous node. And then we say, okay, if not current, right? Or just follow our Python code, then we're going to be like return previous, and then this is going to be like else, and then we gotta save our value of next node before we update the chains. So then this is updating the chains, and then we can just return recursive at our next node, and then it's gonna be our current value. Okay, so I'm just gonna say this local. And this also actually be local. It's weird. That's why there's like all underlined. And then we can just say return recursive. This is going to be our 1 from our example. And then we just got to give it nil. Okay. And then it should work. So yeah, 5, 4, 3, 2, 1, 2, 1, and nil. Same problem, but this is now a recursive function because it's calling and using the call stack. So you guys might be like, okay, so when we like travel through these nodes, right, and stuff like that, what is our time complexity, right? Because it goes like this and then it goes back, and we're gonna be like, wait a minute, does that mean for every 3 we just times it by 2? So I mean, guys, this thing is like, this arrow is just a concept, right? It's just a concept. Just think of doing head.next is equal to 3. So when we say head.next, right, we say a variable is going to equal to a value. This is actually in constant time. So doing this, when it gets like 3, it's gonna be like, okay, we're gonna set this equal to 3. And guys, that is setting a variable is constant time. So that's why our time complexity is O of n, and our space, right? Well, we're not really storing anything because, so hopefully you guys enjoyed this episode. I'll see you in the next one. Take care, everybody, and goodbye.